going to talk about its quotient rule. Instead of writing it all out this time, I'm going to use the book to just go down the proof, all right? And this is quite a bit of work. You have some function f of x up here at the top, and we're going to say it is two parts, f of x divided by g of x. And a lot of times, the problems actually will look like this. You know, x plus 1 divided by x plus 2. The rational expression, if you want to know the rate of change, you have to take the derivative, right? With the defined slope. This causes problems. Power rule will not work here, period. So don't even try. So, we have to see that there's two parts. So we're going to call it f of x and g of x. And again, if you want to find the derivative, you got to take the limit as h goes to 0 of capital F x plus h minus capital F of x over h. And I sure hope that's the first step they do. And of course it is, right here. So they say, hey, the derivative is that definition. And then they insert x plus h and g of x. Now, when you look at this disaster right here, what do you have to do? Common denominator. Let's make this thing bigger and uglier, all right? It's time to kiss your sister. Here we go. When you talk ugly, you talk about kissing your sister. Not on the cheek. This one's kissing her right on the lips. Here we go. See, I don't have a sister, so I never have a sister. But here we go. So listen, they find the common denominator, g of x plus h and g of x, right? And they bring the h up, and here it is. All right? And they bring it across, and they do the algebra. And again, you guys, calculus is not hard. Algebra can be. And we get this nice step right here, all right? And we look at it, and again, this is the case when I look at it, I don't see anything to help us. You guys agree? So they're going to have to add some stuff here. So we can separate f and g in this expression by subtracting and adding the term f of x, g of x in the numerator. And it's just like the last, just for the product rule, you see they stuff these two in the middle. And now we have the ability to see that g of x is common here. And in the second one, two terms, f of x is common there. So it's going to become a factor problem. All right? And you're going to be a separation. So the next step here, if I get it all there, is to pull out the g of x. And that leaves this. And when we see this, everybody, what is this? Derivative, f prime x, right? And this one here is g prime. Now this should seem a lot like the product rule, all right, because it is. But we still got some crap on the bottom to worry about. So let's go down and see where it goes. So, as we scroll down the screen here, we're going to write, they bring the limit in, which we really don't care about, all right? But when we do that, on the top, we get the g of x times the f prime of x, just like the product rule. But instead of plus, it's minus f of x times g prime of x. But think about it. When you take the limit on the bottom, here, you get g of x times g of x, which is simply g of x squared. So, again, you were asking, is this memorization? The answer is, unless you want to do this proof every time you want to use it, the answer is yeah. Yeah, we can go back to the top.
So it's the one that's on the bottom or something.
You don't have to derive it. You just have
Yep,
to know.
the one on the bottom is squared. So if I do the entire page here so you can see it all. All right, the one on the bottom is squared. So here, this was the derivative of f of x over g of x. All right? And again, it's like the product. So guys, you got to memorize these. I mean, that's the long and the short of it. Again, we wanted... It's in your book. Take notes. Don't be lazy. All right. So if I add a page here, so the derivative is this. This is how I remember it. I simplify it as f over g. All right. And then guys, if you want to look at your book, it's on page 154. We'll take a snapshot of here at the end. I write it this way: g of f prime minus f g prime over g squared. And again, this is great for rational expression. So let's do an easy one. Let's have h of x equals 2x plus 3 over x minus 4. All right. Here we go. H of x. If I want to do the derivative of that, h prime. First of all, do we all agree the bottom becomes x minus 4 squared? Because the bottom is going to be g of x. Does everybody see that? based on this. Now, if the bottom is g and the top is f, right? What's the derivative of x minus 4? Derivative of x minus 4 is 1. Right? What's the derivative of 2x plus 3? 2. So here we go. 1 times 2x plus 3 minus f is 2 times... Oh, I'm sorry, I did it backwards. Here we go again. Let's try that again. G is x minus 4. F is 2 minus 2x plus 3 times 1. Distribute, right? And simplify. So this top becomes 2x minus 8 minus 2x minus 3 all over x minus 4 quantity squared. And so h prime of x is, look at that, negative 11 over x minus 4 squared. And just like that, we just did, and now can you imagine trying to do this with the limit as h approaches 0, definition of derivative? It would take us all day. Well, not all day, it would take us 7 minutes. And then the odds of math mistakes are just tremendous with this. All right. So again, this is called the quotient rule because it's a quotient of 2 functions. This is an example. This finishes up everything you need to do all your practice, and this takes practice. I always put it on a quiz. I always get a bunch of F's because there's a whole bunch of guys who never practice. So if you don't practice, expect F's. All right? Hint, hint, hint. All right.